Okay, good morning, everyone. I'm Kim Soler from Hydrogeology Group in Barcelona, which is a unit association from CSIC and UPC. I work in numerical modeling, but in our group we have people working in stochastic, operation, so on. My application is CO2 storage to avoid to emit in the atmosphere, but we have also a wide range of engineering applications, like marine intrusion, mining, etc. But what they have in common? In research, sometimes we are working on a very specific topic, but we forget sometimes what is our main goal, why we're doing this research. And that's why I'm not talking about on my thesis, but on this main goal in my research. And this is groundwater, to supply and protect this water, which is stored in the ground. Not like a big bubble, not like a cavity, but like a sponge. This water represents a very small percent of total amount of water in the world, but more of the 0.5% of the population depends on its supply every day. And this demand probably will increase because of the climate change. For those who are not convinced still of the importance of groundwater, please let me tell this, that probably will, I hope will. The ground can act as a filter of contaminated water, and these contaminants can be very dangerous for the human health. But what is the problem? The problem is that this resource is hidden. We cannot touch it, we cannot see it. And this is a problem because in a large aquifer, someone can contaminate in a point, and then other one can be using this water in another point. And this is difficult then to follow the path and find the point where is the contamination. Other problems we have is that the ground is heterogeneous at very different scales. And also, we're trying to model very difficult processes like chemistry, for example. But we have tools. We have some friends to deal with. We can do computational modeling, we can do laboratory experiments, or we can drill a well and take samples from this well. But the question is, are they realistic? For example, in computation modeling, are we sure that the equations we're using represent the proper behavior under reality? Are we sure that when we take a sample from a drill, the contamination comes from the aquifer or from the surface? And in laboratory experiments, are we sure we're doing the same conditions that we find in the aquifer? We need a very high level of abstraction in this world. Thank you very much.